A little bit about myself. My name is Kye. I've been building AI models now for almost more than 10 years, since I was like 11, 12 years old. I'm now 20, so I've been building models for AI models for a very long time. Just yesterday alone, I built like 12 new AI models for like stock prediction, earthquake prediction, radio frequency analysis, basically any task that you can imagine. I probably built AIs for them, and I'm the leader of SWARMS. And if you want to follow me on X or LinkedIn, you can scan those things. No, I do post very dank memes on Twitter, so if you want to have a laugh, I suggest you do it. So you've probably heard of agents. Agents have been popping up very, very frequently in the past couple of months. Ever since the rise of ChatGPT, agents have been gaining a lot of popularity. And basically, like, what exactly is an agent? They have to like fundamentally ask this question of like, what is an agent? Most people don't know what an agent is. And an agent, in the last like 50, 60 years of compute, agents have a very abstract definition. Anything can be an agent. You all are agents. An agent, at its most abstract level, is an intelligence that has the ability to take action. That is the most fundamental definition of an agent. Anything that can take an action and that has a goal is an agent. Humans are agents. Cats, dogs, cows, agents. And any single animal now in this planet is an agent. But since last year, of this time, March, and since last year, ChatGPT, we have now seen the rise of AI agents. Agents that can do things for us and for our businesses. And that's what we're going to be talking about here today. So what we define as an agent in SWARMS is an LLM plus the ability to take an action on an external platform, and also has long-term memory. So tool usage. What is tool usage? So basic AIs like ChatGPT cannot natively do anything outside of a box. They are in a box, and they have to be given tools to take actions outside of their box. Most AI models now do not have the ability to send emails. They do not have the ability to create spreadsheets. They do not have the ability to take any form of action outside of their environment, which is just generating text. So what we define as an agent is what they need an LLM like ChatGPT to take action on external platforms, like sending emails, managing your calendar, analyzing bank statements, any form of activity that we as humans do with computers is done through tools. You use Gmail, you use Google Calendar, you use all these different tools that help you with those tasks. And essentially, an agent is an AI that can take actions on those platforms. And long-term memory is humans, the average lifespan of a human being is around 80, 90, 100 years old. LLMs cannot remember things for more than like 60,000 words. They just won't remember anything after that. So an agent has to have a memory until the point that it completes its objective. And that's what the long-term memory is. Long-term memory is also known as RAG. So if you've heard of RAG or RAG systems, it's basically the same thing. So agents are basically AIs and LLMs equipped with tools to automate operations in real life. And the reason why they are so beneficial for you and for all living human beings now is that they can automate a lot of the things that takes us a very long time to do. Sending emails takes human. The average email in a work environment takes around 20 minutes to craft, especially if it's for a more detailed scenario. So if spending 20 minutes to write one email nowadays is really absurd. you can have an AI generate a slightly similar or slightly matching quality email in less than, not even 4 seconds. That means you can send more emails, you can get more things done, and generally speaking, your business or your organization can lower its costs, increase its efficiency, and just generally get more things done. And so, here are some examples. ChatGPT is now with the ability to browse the web. ChatGPT can be considered an agent because it has the ability to browse the web. If you say look this up on the browser, like look up, who won the Super Bowl this year, it'll look it up. That's an agent because it has access to a tool. Another really popular agent is Perplexity. So Perplexity is an agent because it basically has access to search the web as well, and that would be considered an agent. So these two are examples of very popular agents that have been gaining a lot of momentum. And Gemini, also from Google, is another agent. So when you use Google now, you're going to see, if you search, you might need to be part of a program, but if you go to Google now and see AI pop up, that's an agent. So that is an AI taking an action on an external environment. And but the fundamental problem is like and you've probably seen this somewhere on the internet. If you're learning about AI, there are a lot of people that say agents are very ineffective. There are people that say agents are not extremely reliable. They hallucinate. They can only do one thing at a time. And these are very, very difficult challenges now with agents. And they are the thing that is prohibiting them from being used in every single business, in every single organization, in every single company, every single school, in every single phone, and every form of technology you could possibly imagine. So these limits, these challenges, we have the first one, context window. So if you've ever heard that word, a context window is basically the amount of memory that an agent can fit into its brain to remember. So if you try to give ChatGPT 100,000 words, it will not be able to remember anything past 20,000 words. And so that is the context window. So LLMs now, like ChatGPT, Gemini, Claude, all the LLMs you've probably seen, all have this fundamental memory problem. They cannot remember things. And that's a really big problem because the average business document, like a lease for a new office, contract, sales agreements, can regularly extend beyond 20,000 words, especially if they're like over 50, 60 pages long. So the limitation here is quite concerning because ChatGPT now can process many thousands of words, especially over 20,000. And another problem that you've probably seen or experienced is hallucination. And hallucination is very bad because AI will just generate information that is not real. And businesses cannot use information that's not real in production. They lose clients' trust, and it might even just completely destroy their entire application or their entire system. So that's been another concern with agents. They hallucinate, they generate all fake information. And I think that's also a problem with just individual agents, including humans, or even cows for that. We don't have access to infinite information. We don't know everything in the universe, and so we're always going to have a significant lack of knowledge for certain tasks, for certain things. But the LLMs experience it much more frequently because LLMs have to be trained. The process is you train an LLM, and it will only know information from which it was trained on. If you try to ask a model that was trained up to data from 2022, and there was no data from after that, it's not going to know anything after 2022. You're kind of stuck. And that's a very big problem. So another very, very big problem is agents can only do one thing at a time. If you use ChatGPT, one thing at a time. That's it. You can't do 5, 10, 50, 1,000, 10,000, 100,000 things all at once. Individual agents now can only do one thing at a time. And another big problem is low accuracy. So AIs now are very, especially for programming, if you ever try to use ChatGPT to program, the code it generates is not extremely reliable. And that's a big problem, especially now that more than 50% of the code on GitHub is AI generated. And that's starting to go beyond 60%. So 60% of the entire world's database of all code publicly available is AI generated. And that's grown very, very quickly. Just a couple of days ago, the CEO of AWS said that by using agents, they saved 4,500 years of developer hours through using agents to help them review their code. And that number is just truly absurd. But those agents they use still have these 4 or 5 problems, and everybody that's using ChatGPT also has these same problems. So, like I said, context window is it's essentially a loop of words of input. And like I said, agents and LLMs will always hallucinate because they're not trained in real time. Humans, we can learn in real time. We can look up, we can look up a website. We can look at data in real time. But for AIs, they would have to be trained from scratch on this data. You have to make a data set. You have to clean the data set. It's a complete mess. And that's a big problem. So, and fundamentally, the biggest problem with ChatGPT nowadays is that it can only do one thing at a time. It can either do, like I said, it can either do 50 things at a time, 100 things at a time. We've been using ChatGPT to generate tens of thousands of social media posts, Twitter, LinkedIn, basically every social media you can imagine. And if you ask ChatGPT to do that, it's only going to do one post at a time, which is not very useful. Yeah, no good. So the solution to all these problems with agents is multi-agent collaboration. It is the ability to enable AIs to work with each other. And we can get them to work with each other by simulating how humans work and just putting AIs where the humans would be. If we do this, if we try to replicate org charts, organizational charts, with AIs as the nodes, it's actually very fast. So through multi-agent collaboration, instead of having an agent that can only process 100,000 words, now it can process 10 million, 100 million, 1 billion words. The accuracy is also significantly, and if not quadratically higher, because if you have agents and AIs that are all trained and specialized for different activities, then you can have AIs debate with each other. And through this debating, through this critiquing, and through analysis, the AIs can significantly raise the accuracy of the end result, which is very, 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 very powerful. Because if we look at human society, all great things have been built by multiple people. There is rarely a major technological innovation that was built or completed through one person. The nuclear bomb, a team, thousands of people. Building universities, Miami-Dade College. Not a single person built the entirety of Miami-Dade College. In fact, most companies are leveraging the power of human collaboration. There hasn't been a single massive Fortune 1000 company that only had one person. And so the power of enabling AIs to work with each other is very, very, very powerful because through this collaboration, they can increase the context window, they can increase the number of words they can take, they can lower hallucination, and they can do many things at a time. So depending on how many AIs you have at once, you can do any number of things at once. If you have 50 AIs, you do 50 things at once. If you have 1,000 AIs, you can do 1,000 things at once. You can generate social media content. You can generate entire products from scratch just by saying, build me this product. It'll build the front end, it'll build the back end, it'll build everything. And you just have to say, I want this, and they'll work together, and they'll build it. And that's kind of the essence of a swarm. In swarm theory, anything that involves more than 2 agents is a swarm. So right now, we are a pretty big swarm. So, yeah. And especially for AIs, if you have more than 2 AIs, that technically becomes a swarm if they communicate with each other. And that's basically what swarms means. We essentially provide the ability for you to increase the accuracy of the agents, decrease hallucination, increase the context window, and do many things at a time, just like humans. So basically, collaboration is all you need. We essentially work rigor. So GPTuesdays models like OpenAI, Anthropic, Claude, Gemini, any form of LLM or AI that you've seen, we integrate into the swarm. And you use tools, so you can input these agents to send emails, update events on Google Calendar, update Airtable. I mean, anything you can imagine, these agents can do. Anything that humans can do now on computers, agents can do, given the right tools. And then we also put RAG systems, community, Pinecone, and familiar database systems. We can all integrate. We also integrate agents from LangChain. So if you've heard of LangChain, they're pretty popular. You can also integrate those agents and put them into the swarm.
Kye, can you also combine different LLMs? Or you always need to work with one model for all the agents?
You can customize it however you wish. You can have 50 OpenAIs, 1,000 clauses. You essentially just make this and match. There's no rigorous requirements.
So do you have like a modulator choosing which one to connect for a particular task?
Humans would do that. But in the future, so
I'll connect you with a startup that is working on that.
So knowing what tasks LLMs are good at is very powerful. For example, Claude, in our experience, is very good for generating contracts. We have had thousands of legal contracts. We've had hundreds of sales contracts generated with Claude. Claude is very good at generating contracts. But if you haven't asked Claude to do this, it's very hard to know that it's good at it. So creating an automated way to know what tasks certain AIs are good at, like ChatGPT or Claude, is very powerful. But for now, you have to just have the knowledge to understand ChatGPT is good for this, Claude's good for that, Gemini is good for this. But that is a pretty big problem that I'm trying to solve now.
They are financed by the European Commission, so I will connect with them.
Thanks. Yeah, so to install it, basically you just open up your terminal and you do pip install SWARMS. And that's it. It's mostly a Python app for now. We are building an API and also implementations in Go and Rust. So except we're on Python mostly, which is one of the biggest programming languages in the world, if not the biggest. And all you have to do to install SWARMS is copy and paste that in your terminal. We are building a user interface now that is no code. But building this has been pretty hard because through an API, you can very easily spin up 50,000 different agents and get them to work with each other very easily. But if you were to do that on a user interface, it'd be kind of difficult. So we're working on that right now, so that anybody who don't really need programming experience could do that. We're going to have a little demo of that pretty soon.
Kye, sorry. Could you explain what $PIP means?
Yeah, so a $sign is basically like in the terminal. That's like if you go on your terminal on your computer, you'll see a $sign. That's and then pip. So pip is Python's package manager. So to download packages from external developers like ourselves, you use pip to install package. Yes.
Do you believe in these agents having like cycles, or are they all acyclic and don't have cycles? Like, what's their life cycle?
Very good question. So every agent has a loop. The loop is what defines an agent. The loop is the most important thing in an agent, because in an agent, basically all an agent really is it has a form of intelligence that has a goal, right? And it has to loop until it has to take actions until that objective, that goal is complete. And so the looping structure is the life cycle of an agent. And you can define the loops that you want. And so you say, I want you to loop 50 times. Yeah. And if you see done, like you set a token, this is done. If you see done, stop the loop.
Is it like an orchestrator that is defining when to kill these off, or is it self-defined and self-ending?
You can loop it forever. So you can set, like a human can set number of loops, or you can say just loop forever until you see this.
I see.
So kind of both.
Very cool.
Thanks. Yeah.
If I'm not mistaken, you can also recycle them, right?
Yes. We do encourage recycling because building an agent. So like we build agents for accounting, for finance. We had to like build agents just to analyze our own bank statements. So we actually have this form of agents that analyzes our bank statements and shows us like how to save money. We had to build those from scratch. But we are building a marketplace where you can essentially put stuff on a marketplace and you can reuse agents that have already been configured. So you don't have to waste your time on that. Another big problem with agents right now, and all AIs, is that to build a good agent, to build a good AI, you need to be able to build good prompts. Prompting is the most, it is essentially the bedrock of an agent. If you do not build a good prompt, the AI will be useless. Completely and utterly useless.
In addition to looping, are there other execution models like a parent-child relationship, like a manager agent that can spawn child agents? Is that possible?
Yeah, just for now, like I'm going to be showcasing those in a couple of minutes, but we're just talking about one agent right now. If we don't understand how one agent works, then scaling up to multiple nodes is going to be a mess. Even for me.
I'm sorry, but I'm thinking about the infrastructure that there is in the backend, servers, sustainability, because that's a lot of agents. So what about the energy, problem? Is that why you want to recycle one of the solutions to make it sustainable?
That's a good question. So if you're using APIs,
sorry, what was the question for the audience?
What was that?
If you repeat the question for the audience.
Oh, yes. Should I just?
So I was wondering, what is the infrastructure behind this harness of AI agents? Because one of the biggest problems that we have in AI is sustainability. So I was wondering if recycling agents was maybe a way to compensate or to make it more sustainable. I want to know, where do you install them, which kind of servers, I imagine it's not hosting, so yeah.
So right now, if you're using an API, you can, right now, on whatever computer you're using, in fact, say probably 90% of the laptops in here could run maybe about 100,000 different agents at the same time, if you're using an API. But because the thing is, especially like all at the same time, you can have 100,000 agents all doing things all at once. But only if there are APIs. So to help a model like ChatGPT, GPT-4, needs 8 very, very expensive GPUs to run. So the models are like, they're called A100s. So these A100s are like $15,000, $20,000 each. And those are stored in data centers. And depending on how big the base model is, that'll be the energy consumption. So if you use an open source model like Llama, if you've ever heard of Llama, that's 70 billion parameters. The parameters is basically like how big the model is. You could run Llama 3 pretty good on like if you run one Llama on like maybe like a gaming laptop. But if you're calling APIs, you're not hosting the actual model on your own computer, then you can run 100,000 plus maybe, depending on what CPU you have.
And does it make a difference if you use an NVIDIA graphic card in your computer?
Yeah, but it depends, because if you have a NVIDIA, so like the newer, like the A100s, all the NVIDIA GPUs for AI cost an obscene amount of money. I mean, 20,000, 30,000. H100s, which are declared like the best, are like $40,000. So with gaming GPUs, which are like kind of cheap, you can get like $200, $300. You could probably run like one, maybe Llama 3, just one.
How many?
One.
One agent? No.
Yeah.
One strong. Yeah.
So there's hosting models, and then there's sending API requests to those models. So there is a fundamental distinction. But if you're using a model like ChatGPT, that's why I'm saying you run 100,000 ChatGPTs on your own computer.
What about if you use cloud PCs?
Cloud?
Cloud PCs.
Oh, cloud?
Cloud PCs. Cloud PCs.
Yeah. So that is if you were using if you were trying to like actually run the models locally, so they're fully private, none of the data is like leaving, you would do that. Then I would advise you put all the like models on a server somewhere like AWS. But if you want to use a pre-trained model like ChatGPT or Claude, then you would just send API requests. You're not like storing. You don't have the model locally. The model's in another data set somewhere.
Yeah, I know, but I know that cloud PCs are the future. Like all business computers are going to be cloud PCs in 1 or 2 years, right? So where does the way we're going to connect to the internet and do anything, right? So I guess that we will connect through the cloud PCs to the APIs, right?
Yeah.
And that will also help to make the whole thing more sustainable at the same time.
Yeah.
Okay.
We SWARMS. We are developing an API right now to host millions of agents all on one computer. So you just type in whatever you want. You say, I want to make a team of marketing content generators. And I want to make posts for TikTok, Instagram, X, LinkedIn, and then you just say what you want, and then you'll get a response from like hundreds of thousands of different agents. So you don't have to necessarily set up that infrastructure.
And do you have a center or?
Us as a company, yeah.
Here,
We have one in Miami, and we're also partnered up with AWS, Google, and Azure. So we have partnerships with all of them.
I will get started doing this. Guys, this technology is coming from Miami. So, born and raised here.
Wow. So yeah, if you want to check out the GitHub, you can scan these QR codes. We also have our documentation. So anybody can get started if you check out the GitHub docs. And yeah. So again, to summarize, SWARMS enables you to orchestrate multiple agents in different structures. There's what we call different architectures, and I'll go to what those are in a second. But basically, we allow you to simulate essentially digital humans that do things at scale. So any task that humans do now digitally, like marketing, programming, sales, accounting, finance, anything can be simulated with agents. And essentially, agents can match the performance of humans, if not totally exceed them in some situations. So now, the very interesting section of this presentation is the swarm architectures. And these swarm architectures are essentially it's a form of how the agents communicate. So the communication within the swarm is how it essentially defines the performance of the swarm. So right now, most companies are hierarchical. Hierarchical means that there's a boss, we have a boss, and the boss is giving tasks to workers. In this case, you have essentially a series of agents, and the boss will give them all tasks, and then they'll all do those tasks. Companies are hierarchical. Even governments are hierarchical. You have a president, you have chief of staff, secretary of defense, whatever. Most human organizations are hierarchical. There's the boss will give tasks to humans or the workers, and then those workers will go do the work. Those workers can be engineers, they could be salespeople, they could be accountants, etc. And so that is right now one of the most popular swarm architectures. It's just building a boss agent that will then go out and build other sub-agents that will do work for us. So we don't have to build agents if we have a boss. The boss will build them for us automatically. And then the next swarm is the parallel swarm. So the parallel swarm is you giving a task to multiple agents all at the same time, and they're going to go out and do that task. And they're going to have different results depending on their performance. So basically, to give you an example, let's say like a teacher is giving out homework to all the students. That is a parallel swarm. The teacher is giving a task to multiple people, multiple agents, all at the same time. So that was very popular for like team-based work. So like I said, if you wanted to have like different social media strategies, you would essentially use parallel swarm to get them all to make social media content at the same exact time for different clouds. And so the last one here, and probably the most simple, is the sequential swarm. So a sequential means that I do something, let's say I'm an accountant, or I'm doing a business, right? I'm going to do something, and then I'm going to give someone else my work, and then they're going to give someone else their work, and then they're going to give someone else their work, and kind of a chain or a loop. This is also like very frequent in programming. So if you program, you have to make code, then you have to give that code to someone else who's going to integrate it somewhere else, and it's kind of like a loop. You have to do something, then pass your work off to the next person or agent. And so these are the three most popular swarms. You can mix and match them however you wish, but like I said, the most popular one is the hierarchical, because that's how humans collaborate. Humans are mostly hierarchical. There's a boss, there's some form of director that is giving tasks to other agents. Yes?
So, like, say you're an NFL line, right? The quarterback is giving signals to the line, so you change the play up. But the linemen themselves, like, communicate blocking schemes in real time as well. So where are the lines here if the swarm can communicate? Like, NFL linemen have to.
So the question is, say these swarms are each one's an NFL lineman. The NFL linemen actually have to look left, look right, and communicate what the block is in minutes based upon the vendor in front of them and how they change as well. It's not just the QB and coach, doing a top down or even any of those swarms really. So where's the future communication between the swarms?
That's a pretty interesting swarm architecture. We haven't built something like that, but that would probably be a combination of both parallel, because they're all on the same line, and there's sequential. So it would probably be like a mix and match of both of those two. But that is a pretty good idea. We could actually probably build something like that. So that's actually very interesting. So yeah, those are different swarm architectures. Every day there's new architectures. The architecture will mostly depend on what problem you're trying to solve. So different problems, different business problems have different requirements for these different types of swarms. Like a school is fundamentally much different than a company. A company is much different than a nonprofit. And a company has different swarm architectures than like a grocery store or even like a church. Churches have different communication dynamics than most companies and most other human organizations. But the thing that matters is these are just like templates. The fact of the matter is that you can build your own swarm with our framework, and that's what matters. Most problems, especially business problems, are going to require a combination of these three architectures with other unique components. So being able to understand what type of communication and how much communication is needed is very important. Not only for agents, but also in our day-to-day lives. Like it's kind of like, when do you talk to someone on your team to help you with something? It's the same, or we're essentially solving that same problem of communication with agents, with AIs. And so now let's get into some use cases. Marketing. So one of the first and one of the simplest use cases with agents is marketing. You can create a team of specialized marketing agents for each social media platform to post to essentially post specialized and optimized for that specific social media. So you do LinkedIn, you do Instagram, you do Twitter, Facebook, I mean, you do any social media, really. You would just have to build the agents for that social media. So, essentially, to run the agents, you would essentially, I'm going to get into the info now so you can see how easy it is. So I'm going to show you how easy it is to build a swarm. You can basically build a swarm in, what is that, 7 lines of code. We have made it so simple that it's basically anybody can use. Basically, what we have to do is you give the name of the agent. In this situation, it's Twitter. So we have oh yeah. So that's basically what the data looks like. You give the name, you give the system prompt. The system prompt is undoubtedly the most important thing in the entire agent. The system prompt is the instructions that you give for that agent. Now, within these instructions, you should be very, very, very specific. You should be so specific, you probably cannot be more specific. And if you do this really well, then you can show it, you should, and it's worthy that in this case, we're going to say create content for Twitter that is optimized for Twitter, right? Because such as the best Twitter posters that go for developer and AI, and then you keep going. You basically have to give it instructions that are very, very, very specialized for your task. So you can, depending on what task it is, like in this one it's Twitter, in some cases it's analyzing extras, and in some cases it's analyzing radio. And so for those prompts are much, much more, considerably more difficult. But here we're just saying create post that is optimized for Twitter, and that's the second thing. And the third thing is the model. So the base model that you're using is kind of like the center of the brain. The tools in the memory are like other corners of the brain, but the LLM is the center of it all. Depending on what model you use, the performance can go up or it can go down very quickly. So GPT-4, the performance of GPT-4 is significantly, it's undoubtedly one of the best models that there is. So, you use GPT-4, and, it'll probably go good. You can also use Claude, you can use Gemini. There's a lot of Llama 3, there's a lot of these LLMs that have been released, and you can use them to build your agents. And so those are the three big things. You also have the loop that I hear you say, we're just saying one loop. So the agent's going to just generate something, and that's it. In some cases, it can be much, much, much more complex. We can set this to infinite just by saying, so if we set this to auto, it'll basically go forever until it finishes its task. And it'll never stop, basically, until it is definitively certain that the task has been completed. And that's it. So like really things with the agents, you give it a name, you give it a prompt, you give it a model, and then maybe sometimes, in most cases, having this one loop is pretty simple.
Could you highlight the prompt, system prompt?
This?
Like, listen to it.
Oh, yes. This is not very organized.
Word that.
So this is a very simple system prompt. Here we say you have to create Dade size and expense to maximize engagement. Consider hashtag timing and content relevance. And so these are quite system prompts. Some good system prompts can run into, tens of, thousands of lines of code. So that is something to keep in mind. But the first demo that I want to showcase is the hierarchical SWARMS, because it's undoubtedly one of these simple. So the hierarchical SWARM is we don't have to necessarily build these agents. We just have one agent that builds these agents for us. So I'm going to show you what this looks like. This is the prompt review box. Your boss agent, your primary responsibility is to manage a swarm of work agents to efficiently, effectively, and skillfully serve the user. Then this is the code we're using, OpenAI's function calling model. And these are some of the settings. This is the system prompts. These are the number of codings that we can generate. So max sentence is a parameter that specifies how many tokens the AI can generate. In this situation, it's 5,000. Here we have some code to create agents with the boss. And this is like, basically, this is a sense that we're going to create an agent with these settings. The boss is going to create names, it's going to create prompts, and in future iterations, it will then generate the LLM, it will generate the number of loops, and everything else, basically. So, you know, if you wanted to generate your own agents, it would take a lot of time. But with hierarchical, again, what we have to really do is just literally specify like, what do we want the boss to do. Create a team of AI agents that are optimized to write code for front-end design. And that's what it will do. You say, you know, like, hey, Samus, I want you to help me lower my operating expenses. It would help you create those agents that are optimized for that. And so we're going to run a little demo here. We're going to generate some videos.
Okay, so if you would like to combine two models or more, how will you do it? Because I see that every agent has the word model. So what if you have multiple models?
Yeah, I actually do that on the site. The thing is, I'm just going to go multi-hyper because I live stream a lot. And people take my keys. And you're calling me to take my keys.
Disconnect.
Keys, essentially the AI keys are the most valuable substance right now. They're more valuable than the oil. They're more expensive than we are experimenting with an interface that should be very simple for anybody to use. No code experience necessarily. Okay, well we have a demo with our very experimental UI. So this is another form called the spreadsheet form. And so basically this form makes it very easy for you to manage all different agents on a spreadsheet, like a CSV file. Now within this file, like the CSV, you can essentially customize the agent for a task. So it's basically like a spreadsheet. Now within every row, there's different agents. Here we have the chat interface, so we're going to give it a task. So we're going to say,
Gary and see.
yeah.
So here we're going to say,
social media posts advertised as SWARMS, we say these SWARMS framework, and you'll be able to see that also. So here we see the LinkedIn marketer agents, which is going to go first. Then we have the text agents. We have an Instagram marketer agents. And we keep going. We have Facebook. And yeah, so you just. This is crazy, huh? Yeah, so on the side here, we can customize the agents. We can say.
And Kye, can you also automate that with Make, for example, so that it posted directly into your accounts and
Yeah, absolutely. To do that, actually, we use a tool. So you say, I want you to post to x.com. And then once you get into the tool, then it'll just automatically post through function column. So how the way that Fluence works is basically an agent will output JSON. If you know what JSON is, it's like a very structured data format language, and that JSON will be parsed. And then on the parameter, the agent is going to say, I want this function to say, I want to post on x.com. It'll post that post on x.com through this JSON. And so the way it works is we parse, then you execute. But yeah, this is a pretty simple develop. I'm going to showcase another one right now, advertising GPTuesdays, because GPTuesdays is amazing, right? Oh, this is so. See, really big. Let's create. GPT Tuesday, a gathering of AI engineers. Here's the link to the calendar. Stop.
Link. Fine. No time.
Yeah. So it's also links. It says like LinkedIn, X.com, Instagram. You just like the thing is that you have to customize the agents here. So we were saying you have an agent for LinkedIn, agent for X, agent for Instagram, agent for Facebook. We can add agents. Would you like to introduce yourself? Okay.
Hello. I'm sorry to be here. This is awesome. This is the first time we're doing this in this space. Congrats to Grant and everybody here. This is such a fun thing to be doing. I'm really happy. And yeah, we worked with Dade. It's been a fun week. It's been very informal. To give you a taste of what Dade's life is like is he pretty much wakes up and he just streams himself coding all day long. And people will randomly pop in from around the world and watch him code. So like yesterday, a guy from Australia hopped in, another guy from Las Vegas hopped in. So yeah, he's super accessible. Another thing too is I want to give that props to the guy who wrote his build. I mean, the title of this talk is Applications of Agents for for business. And one thing that I was really impressed by is his website. Is this, this ton of pages, ton of copy. He just had an AI generate all these pages for his website and all the documentation for his screen, right? And going through it, a lot of it has some flaws, and I'm like, okay, well, this is genius. Like, he had an AI generate a whole business for him, like all the copy, right? A lot of it is incorrect, but he's still applying in motion. And I guess collectively, I can help him fix it, right? But a lot of this stuff is it looks super professional, right?
Yeah.
I asked him what do you know, how this supposed to work? I don't know. I think that was pretty genius. It looks super professional. Another thing, should I take the street? I had some other business applications that I didn't think of. He told me that I was welcome to speak yesterday, less than 12 hours ago. So, it was, I had these challenges for the fun, before I came up with it. Yeah. And Nick, right? Nick is right on that. This guy's just jack of all trades, super helpful. He's offering me food. I just met him like 5 minutes ago. He hasn't had Micah told me one time, Micah here, by the way? No? Didn't make it there.
We're almost there.
That's a little bit better, right? So yeah, okay, oh. Alright, cool. So I have 5 applications of this technology that he's been immersing himself into over the past year or 2, building a whole company on top of this idea of leveraging swarms of agents to, get things done, so to speak. So the first one that I came up with is, here I have a book called $100 Million Offers by Alex Ramosi. Yeah, what's up?
Yeah, can you go to the screen?
Yeah, that's right.
Just present. Right there. Yeah, sure.
Thank you.
Whole window.
Thank you.
Yeah.
Thank you. Okay. We're good? So here is the first application that I'm going to show. So here is a book that I was wanting to read for a while, but obviously as you grow up, time is a scarce commodity. So what I did is I gave this book to 100 agents and asked them to, I gave each page of the book to an agent each, right? And I had it generate like maximum 3 sentence summary of each page. And now I have a version of this book that I can quickly read in, minutes, right? And so that's the first business application. And this can be applied to like document review, contract review. There's a lot of applications for this is what I'm naming. And the next one that I have, okay, so here is, so this is one of Kye's swarm architectures. And he called this one the rearrange swarm architecture. So this use case would be for doing, I guess, preliminary research about business ideas. So I know there's a bunch of entrepreneurs and people who have business ideas in the audience. I know there's Ben here. I think I saw him somewhere. There he is. Yeah. And so he had an idea for a end-of-life document management SaaS platform. So what we're doing here is we're going to give this business idea to a swarm of historically great businessmen and women. There's phenomenal women in the industry as well. So we're going to give it to John D. Rockefeller, Warren Buffett, Steve Jobs, and they're going to analyze this business idea. And then you're going to have to debate on it. Yeah, you have to debate with each other, like you have about it, right? So that's here you have John D. Rockefeller giving his response to this idea. Here you have Warren Buffett giving his, obviously this is kind of like creative, but you can probably do some in this game, like with contract negotiation, you can kind of like do scenarios with agents, right? And see like how things will play out and help you be prepared. So I think we did 3 use cases so far. We did the use case with generating social media marketing content, en masse. We did the document review in parallel, per page, and we did, contract negotiation, simulation kind of scenarios. And the next one that I have is for screening candidates when you're needing help and you're delegating out things for your business. So this use case is where you'll get a bunch of resumes, right, or maybe straight profiles of different people who you're interested in working with, and you can feed that into AI, right, and then have a prompt where you're specifying what we would like, and the AI will do all the recruiting screening and all that for you, right? So So I gave 3 resumes. I can do a lot of this one. So here we're going to do a batch of resumes. So I think Christian, you get. So we're going to give my resume, your resume, and I got from San Francisco resume, right? And we're going to say we're looking for an amazing programmer, right? And we're going to see who the AI selects, right? Right? I'm going to guess it's a guy from San Francisco, right? So let's go. So you're going to drag, right? We're dropping. This could be 100. This could be 1,000 resumes, right? So here we have all documents. Here we're going to say, looking for expert programmer. Having close to right. Anyways, they need to be great in iOS and Android. A bunch of typos, but oftentimes it doesn't even matter. So hopefully it is wait, I'm going to say, yeah, and here he was asking about any swarms. All of these swarms always have to be the same AI or the same system. You can mix and match different AI systems, and that brings to mind another potential use case. I mean, unless all the AI is going to be lying to you, but if you wanted to assess the truthiness of something, you could give a prompt or ask the AI something, and you could ask 3 or 4 different systems. If they're all saying the same thing to you, right? Probably like there's some consistency, some little higher level of data on some log and anything. But it all says something different, and it's probably not a good application of this technology. But that would be another use case, or to do. So you can have some programming resumes. So, got our resumes, we need our prompts, we do our AI, review. Here we go. Okay, so we now have a swarm of agents reviewing all these resumes, and it's going to, hopefully this should be
But could you there also assign a model for each of the agents? Let's say that you have 4 different agents working on the task. And you say agent 1 is going to use this model, agent 2 is going to use this other model, agent 3. Is it?
Yeah, no, you could do that. The application build needs to be, enhanced to do that. Ease of use, so you 100% to do that. And so here's what happened. It probably wasn't very confusing in the UI. You can find out more information down here. Let's see what it says on me, right?
So then, could you have given it the prompt?
There's different modes that you can, like we were talking about these different swarm architectures. So like for example, you could give all these resumes, and you could give each resume to one agent in this swarm, right? And then the agents, each agent could give it back to you, right? And you could then review it yourself. Another architecture would be like this hierarchical, as you pronounce it, but different ways that you organize these ones, right? You could give the resumes to each agent in the swarm, and you could have all those agents pass back their review to one, I guess you call him the lead recruiter or something. He reviews all the reviews of the other ones, and then he chooses the best one, as you would say, right? So yeah, it's your creativity of how you want to organize these things. But yeah, that's great. Let me pass it back to Kye, but that's
I have a question. The book that you sent to 100 agents.
Yeah.
At the end of the day, you then have to read what 100 agents wrote rather than just one book. So how do you merge it all into one?
Some guy has a response.
Summarize.
Well, here in the UI, I don't know if this lays this one out. I mean, it's somewhat usable. It could be better. Maybe I could work with you to make it.
But you have to summarize 100 agents, what the 100 agents found, right?
Agents can call you, and they'll speak to you. And they'll be like, this is page 1, page 2.
It depends on what you want to do. Like the thing is, sometimes with these LLMs, if you give them a lot of information, they tend to, even if you heard the term hallucinate, you heard this AI hallucination.
Yeah.
So if you want to stay closer to the source material, you could give one page at a time, right? So it depends on what you want to do. It's kind of similar to the previous question that we got. It's like, how do you want to orchestrate these agents for your task, right?
So Tad, this question is more like, when you said that you assigned it to 100 people, right?
Yeah.
You didn't have to go and read 100 different people's responses. How did you get them all to one based on the 100?
Oh yeah. So
Did you prompt it and say, you're 100 different people, give me a summary? Like.
So you have one of the architectures, the hierarchical swarm, right? So you have one kind of boss agent, but then he has 100 workers, right? So the prompt comes in, it's like, okay, I have 100 resumes I need to review. He delegates each one out to his workers. Workers would give his feedback back to the boss. The boss now sees the review of all each of the 100 agents. He reviews it all, and then he gives you the final thing, which in your use case maybe it'll be summarizing all these 100 pages into one, or it could be.
Kind of has a demo of the agent actually take that summary and call you, give you the result of what it found out based on the summarization. You can have another agent take the summary and then summarize that into a voice call. Simplify that and read all those simplified pages.
So this is remember he presented the no-code, very simple to use UI version of the form. But here's a much more technical and much more flexible and agile form. So this is the hierarchical form. And so basically here we just say whatever task we want. So we say create a team of these people. In this situation, it's a team of good marketing strategists. And then the boss is going to make each agent. And then for the boss, we're going to put all those agents into a spreadsheet. And we're going to get them to go to work basically.
You zoom in?
Oh yeah. So here's the thing this form with a market strategist that specializes in launching new products in small agents. The agents must output the details of the market strategy for launching a new product in the market. The agents should be specialized in different perspectives in business, marketing, sales, and product development. And then the product is the small agents, basically us. After this, I'll be asking people what they really want to see. Say you can play around with it and just go over the power of the system.
How are you applying the models?
The boxes. We don't, this is the only input that we're getting. That's it. So that right there, we can just solve is all those agents running. So I don't know how many agents are yet, but we're going to see the spreadsheet. So from the looks of it, we just have 4 agents run a couple of times. So this is going to generate a spreadsheet. So this is a spreadsheet where you can see all the different agents and all their outputs. So this is a strategy agent. Let's see what it says. Yeah. So the go-to-market strategy is SWARMS management. The new SWARMS management system tool is to facilitate the orchestration and management of all agents or operating in SWARM. The tool has been applications in various industries such as robotics, logistics, agriculture, and smart cities. So basically, we can essentially navigate the go-to-market, like our potential go-to-market strategy by having these agents with different and diverse perspectives. Essentially, come up with different go-to-market strategies for each idea that we might have. So, to target market segments, we could potentially do deals with robotics, organizations developing drones, autonomous vehicles, logistics and supply chain. So the company is looking to optimize the warehouse operations and delivery systems. We're actually right now talking with Walmart. I met up with the CEO of Walmart, Doug, and there's certainly a possibility that they may be integrating many hundreds of million agents for their logistics. So this is correct. Agriculture, businesses deploying forms of drones for crop monitoring and management. Right now, we're working with John Deere, with drones, so with tractors. So autonomous tractors, and hopefully, I pray God, one day we maybe partner up with the city of Miami to, integrate forms for traffic, pollution, resource management, cargo collection, security, and etc. Hopefully, pretty soon cities will become intelligent, because now there's many people in cities, but cities are mostly, cities are mostly stagnant. Imagine if the city was like a big brain with like humans, animals, cats, dogs, the city is like a swarm of many animals and buildings. So hopefully, in the future, we'll do that. So hopefully, this is a pricing model. This is great. My question was, what's the combined strategy? We want to be using retrieval long generation, corporation. We have to see out there. Is there opportunities to deploy that across my own worship or lines? Can you shed some light on how are we refining over time with the retrieval? Is that right? Or are we fine-tuning type of strategies as well? So also think about compliance with strategies. So the demo I just presented, spreadsheet form, this SWARM is running mostly locally. So these images here are like essentially everything comes locally. If you want to host your own models, like Llama 3, you have to get GPUs for this. But these are all running on a computer. This is not a server somewhere. The entire SWARMS framework is this data is completely local. So we're not really capturing any data, and everything runs locally. So HIPAA, if you're talking about HIPAA, is that right? If you're talking about HIPAA, that is that we implement some security measures, but everything already runs locally. So yeah, the only data that is going in and out of the system is the API that you're sending to the cloud. The API that you're sending to OpenAI. And if you use your own files in the cloud, like if you use AWS of Llama 3, there's no data being sent anywhere at all. So if you want to make everything extremely secure, you would probably put a host model, Llama 3, in AWS, and then just basically like send an API request from your MacBook or whatever system that you're running.
Is that, could you also add the observability aspect on how to, like differences between fine-tuning versus prompt engineering versus creating a custom model, and what are the trade-offs?
Yeah, that's a good question. So fine-tuning is very complicated and very, very costly. So prompt engineering is the simplest tuning you can do to make it better. In fact, the prompt is going to be 80% of the user's performance. It doesn't matter how good of a model you have before that. Like GPT-4, best model ever, it's really, really dumb and useless if it doesn't have a good prompt. Like it just will not do anything you wish. So prompt engineering is like number one. Second is for like optimizing agents. Number one, prompt engineering. Second would be RAG, so integrating long-form memory. That does add some additional complexity to your application. You need to be experienced with banks and databases and stuff like that. So that can add a little bit of complexity to the project. And then the last massive optimization you do is fine-tuning. But it's very, very costly. Because you have to get a big GPU, in fact, a very, very big GPU, to fine-tune the model right wrong. And OpenAI's fine-tuning is very expensive, and you don't actually own the model. So you're literally paying, you're paying OpenAI to fine-tune the model for your use case so they can keep it. That's hilarious. It's like, I don't know, but that's fine-tuning. If you want to fine-tune a model in laundry and make sure you own it, because I guarantee you're going to spend a lot of money trying to make sure it works well, and in most cases, it just doesn't go well. That's why it's like the last case scenario. That is like the last thing you do. That is like a very good question, because honestly, I would just say focus on prompts. Focus on prompt engineering. If you want to get a lot of data, only in the act of giving the AI a lot of information would you use a RAG system. That is, like, if you want to give like many thousands of documents, for example, like you would use RAG for that.
Yeah, I am. So I'm a consultant at Fractions here. Most of the clients that I've worked with in the last 6 months, they all have a combination of RAG versus like a fine-tuning strategy for improving their models. It's just, traditionally speaking, they're all these organizations that's been around for at least 10 years. They would have the time to machine learning on like institutional context, databases, data. So there's a long chain of where you actually go from. If you go with a limited approach to finding models, like retrieval generation, which is using fine-tuning. It's just something that's really it's the issue.
Yeah, RAG is much simpler than fine-tuning. You need to have experience in linear algebra, calculus. You need to go to manipulate the internal mechanisms of a model, which is not very easy, even for me, and for other people that are doing this for some time now. So it can be very cost.
I also just want to make a point on fine-tuning that it only acclimates a model to fine-tuning only acclimates a model to respond better to the flavor of a certain type of prompts, but it won't be the precise data or your prompt. So rapid, a more precise accurate response, right? Because it's putting in your data versus like a feature-wise kind of response, right? Yeah, and I think prompt engineering, like you mentioned, wrapping a prompt to get more specific instructions is a good way. I also want to make a point that like an 8 billion parameter small model from 3.1, you could fine-tune it and generate synthetic data using an agent. That's one example, but like GPT-4 would be very expensive because of the size of it.
So that was actually one of the first use cases with agents. So it was actually using LLMs to generate data to train other LLMs. So, and that's actually what we're doing that on a pretty massive scale too. Generating like raw data to train teams specialized just for marketing, law, accounting, finance, programming, like that would essentially be like if you want to create your own units that are really good for very specific things, that's when you would sort of hire them.
Yeah. Also, regarding financing the rack, and how is it, what did she move to a big corporation already? So if the funding is there and they have a budget, they might, kind of assume their model, specifically for, on that data that they communicate about, the use, right? But this is the money. So, depending on the use case, sometimes when you take that far.
Fine-tuning can, we've seen that like fine-tuning can sometimes run into the thousands of dollars. And sometimes you get there really fast. If you use a provider like OpenAI would be absurdly expensive. If you want to fine-tune a global model like model 3, you can simply just run the GPU for $2 an hour, and you can fine-tune a model pretty well in a couple of hours. But then you have to develop code. There are some services that handle fine-tuning for you automatically, like Together. I've used Together in the past to fine-tune models for finance, and it's quite simple. But it's still like not as, you can dramatically lower the cost if you just run it locally. Does that answer your question?
What was that service that Together AI to fine tune?
What was that?
What do you use to fine tune the models?
Together. They call Together.
Together, yeah.
Yeah, it's kind of simple, but not really. Well, first thing you need is data set, right? Then you need to put the data set in a specific format, and then you submit it to Together. But it can be tricky because to be good at fine-tuning means that you need to know how models think. To know how models think, at a very deep level, you need to know extremely advanced forms of math. Advanced calculus, multivariate calculus, linear algebra, and if you know like the deep mathematical algorithms behind these models, fine-tuning for you can be very easy. If you don't know these algorithms really well, it's impossible. It's like magic, basically. So those are some things to keep in mind. Now I want to ask, I'm very lovely human beings. There's some ideas. What would you like to see? This is the hierarchical form, so we can be creative. We can see anything.
Before we do that, my question was, when it comes to the architecture, do you choose it, or does it, like, based on what you want, it give you the most optimal assignment for the architecture?
Both. So in the second case, if you wanted it to automatically find an architecture that works for your task, you would use the hierarchical as well. But automatically, like, if you don't use that one, it's not going to know. So you have to either program it yourself, like I did here. I know this file is only like 340 something pages long. But here I'm saying like this is a spreadsheet form. So the boss here in this file is creating a spreadsheet form with all the agents that it generates. So yeah, I can showcase it to you again in all this stuff. I just need an idea. Does anybody have yeah?
Yes, we put that on the screen.
What's that?
Share the screen.
Oh, I think I have.
Is this one? Yeah.
At the bottom.
Yeah. Oh, that. I think it's got to share something. Share screen.
What's up? Alright, yeah.
Alright, so create a swarm of a group that is marketing music and have one agent be a songwriter, one a school
Create a smart business for what?
for producing music. Yeah.
Like that?
Yeah. And then one agent will be a songwriter,
Oh, I see. I see that.
and then one marketing on streaming platforms, and one interacting with fans.
What was that?
One interacting with fans.
Oh, I see. Marketing.
Marketing,
So one would do the songwriting, one would do the marketing.
like fan page, streaming platforms, marketing. Was this the part that you said before be as specific as possible?
Yeah.
Okay. Yeah, so then,
It's like a whole music industry, basically.
yeah, so then, a songwriter, wait, do you want me to be more specific, or you want to just run the back and see what it is?
Let's see what happens.
Can you word wrap it? Word wrap? View, go to view. Make the one link. Go to the view tab, top.
Like this?
Yeah, exactly.
It's just adding in more information. I don't know, it was like a long way.
So now all the agents are running, it's running very fast. I don't know how many agents are running. So, wow, we just had 30 agents.
Where's that?
You can run, you run like thousands of agents on a simple macro.
M1 chip or better.
Yeah. So look at this. We got a result here. And we got a song here. So we say agents are nice. Where the agents are.
How do you know what the links are for these? Like,
If
is
you
there
say,
sort of like a program book or like something where you figure out what's your limit for what you can do?
what's that?
What are the limitations? Like, how do you know the limitations? Is there like a guide or is there something that allows
You
you?
just gotta see. I don't know.
Just what?
You just gotta figure it out. You gotta just
You know
keep,
if you're doing it or not.
yeah, just keep pushing the limits, you know? Yeah.
I have a question more regarding prompting. So the variable that is in machine learning are doing our job, and I'm sure all of us have seen if you said one of us doesn't specify our prompts correctly, we're going to get a bunch of garbage and models since we have in context for certain use cases that we do day to day. And mostly I was curious about advice for all of us into how we can better prompt to specify the task that we want done to the agents. And more like a user education kind of point of view, giving like advice, guidelines, services, how you specify the task that you want done to the LLMs.
So I'm gonna show you a website that I think is really,
And dropping?
no, something much. So there is actually this, so it's this website called prompting.ai, which shows you how to prompt really well. So there's different prompting techniques like zero shot, few shot learning. And the best format that I see is essentially like you have instructions. So you say you have like 5 bullet points of how you want the agents to do something, and then you say then you give examples. So you first give instructions, and then you give examples. And by far, this is undoubtedly the most effective prompting technique that I've seen. But these structures have to be like pretty lengthy. Like, I'm going to show you our marketplace, the agent marketplace. We can essentially like find concepts and pre-built for different tasks and also agents. And so we'll look for a random prompt so I can show you. So this right here, what you're looking at is our marketplace. You can essentially change, you can buy, you can sell, you can post prompts or agents or swarms of agents or even tools for those agents. It's like a full stack marketplace for anything agent related. So I'm just going to scroll through here to find the video prompts so you can see exactly what that looks like. But the way that I typically like doing this is that you have a really good and long system prompt that has the instructions. I can show you, so if you wanted to see now, like, in a good example of that, right? This is what a good prompt looks like. You basically, you say, you give it clear objectives, and you do the instructions. You say, when the task is presented, for example, I see the reward pages, you basically have to teach it how to think, and why to think that way. So you have to be very, like, you have to literally instruct it to do what you want to do, as if you have no pre-collection of what you want to do. That was a quick question. At this point, maybe have 1 or 2 more to go and move from there. But one of mine, I'm thinking about is, what if we had little agents that handle for the GPTuesdays Discord for Eduardo, one for the Telegram, and also one for, we use those two. We use those two. All right. Or for the Luma commerce. What would you say Wolfson?
Discord.
Can you send me the Telegram link? Absolutely. I'll send it to you. And you know how okay, sounds cool. Cool. I just sent your Telegram, the Discord, and the GPTuesdays calendar. So what he wants to build QR codes for GPTuesday by essentially telling the agents to build these QR codes. So to get QR codes typically costs a lot of money. Because, capability or whatever. So we're going to generate a QR code for these links for free by having these agents generate code. So the agents are ready to work right now, and we're going to see the output here pretty soon. So look at that. Here's the QR code. So in the generated code, here we said this is the Telegram QR code agent. This is the Discord agent, and then this is the Luma agent. And so here, we have these agents generate code for the task. So the task here is generate my upload create QR codes for the specified links. And there you go. Let's see if it works. So we're going to copy this code, and we're going to then put it in try out. Again, this is free QR codes. So let's see. Yeah. I was trying to find the image. Oh, which one is it for? Maybe it's going to work. Everyone get out your phone?
Can you put it again, Kye? It's done going to expire. I think the link that you have is not.
Oh, that's the final.
Wait.
Ask the agents.
You need to tell it more.
I think you should know. Actually, let's we have any multiple.
I think it's just that the link is expired.
Which one?
The Telegram.
Okay.
So I think we need, do you have your about that?
Maybe not. Yeah.
It's expired.
This is the Luma. Okay. This is the Luma. Okay, so this one I know.
It says expire link, Kye.
Yeah, look at that. I never said we could do this. That's wrong for a second. Oops. Okay, we got another one. Okay. All right, so another one. This might be a little one.
Another one.
It worked. It worked. Let's go.
So how are you doing the orchestration logic? Like, were you doing leader election algorithm, bar, EXC? I'm just curious about the method by which you're doing the orchestration of the various agents. And a use case that could be, if I wanted to prioritize maybe 2 local agents within my private cloud. And say like the responses came back, say a precision coefficient, say underneath 50%. Maybe I want to defer to a different agent.
Yeah, so if you want to check out the scripts, like here, the scripts, the boss is just creating multiple agents through function calling and then sending them a task to each one. So basically, you have bots send tasks to workers do something, return the results, basically. It's nothing that's complicated, like, it's nothing crazy. In the future, it will be like an election algorithms, and that's pretty cool. I'm going to learn more about it. We probably think it's fun. And what was that question on use case?
Could you check the Discord? There's an Anthropic. So there's a link in the Discord. And drop it in general. Yeah. So does that, you can log in. Does that answer Alex's question about how to create a prompt? So, okay, it says press Y, but it said generate a prompt. It'll actually help you generate a structured prompt by typing in a simple question. It will actually flesh it out for you.
Can you put the code of the
What was that?
Can you put the code of
Oh, yeah. We're actually now on
That's Telegram, that's on it.
Yeah, we keep that one.
How do you know? Because it says Telegram. On the other.
This is the little thing.
Yeah, no, just talking. Can you go to
But
the?
even Telegram one, because that one was expired.
Oh, this one?
Yeah, thank you.
That was.
But yeah, so amazing. I think we're gonna go from there. That was an amazing presentation. Everyone.
Amazing. All I can say is that I'm so excited about this collaboration partnership now with Miami Dade College and AI Center here. This is what we do every single week. We provide the most innovative, really aligns with Kye Gomez, SWARMS Corporation. Everyone, that's exactly what we provide. We do this every single week.
The galactic swarm.
That's right.
It's actually
100%. What's the name again? The Galactic SWARMS Corporation. It really is. And it's looking true, too. At some point, it will be galactic. It'll be across the sky. So, without further ado, I want to say thank you to everyone here for attending our very first event at the AI Summit. This is one of many. We're going to be providing not only the AI station that we've got Tuesday, but we're going to be able to expand as well, providing workshops, mentorships, etc. Speaking of which, I want to do a few announcements and a few updates about what's coming next. So we'll have on September 6th, Kye and GPTuesdays, SWARMS and GPTuesdays, will be having collaboration. We're doing a workshop over at Society with you. So if anyone wants to learn how to do this more hands-on, and actually get your hand, your code, and actually build automation and automate business processes using SWARMS and other frameworks, and just generally using agents, come on by to our event on September 6th. If you want information on Luna, I'll go ahead and share that with the business in the know. And also, tomorrow, on Wednesday, we have software internals. Alex, you want to say a little bit about it?
Monthly, first Wednesday of every month called Software Internals, and for engineers and researchers, we do lectures, talk about internals like databases, operating systems, data engineering pipelines. I'll also add society input. Come up to me after this if you want a link to the remote event, and thank you.
You are going here for the events on Friday, so if you want to come, sit a little bit. It's society, very beautiful place, and we're setting you show you how to build your own swarms in the code, give you radical flexibility and control over your agents. So it's going to be very fun, and it's also going to be devoted to actually solving real world business problems. This is the very first workshop from Tuesday. We've been working on this in the pipeline for a few weeks now, and so we're very excited to be releasing this. Besides that, we have more announcements from you have something we can say about the Stronghold AI Summit. This is very exciting. I cannot wait for this. It begins in October, and here you are.
Yeah, hey guys, I'm Prof. I think I have most of you here. So we have a two-day conference coming up called Strong AI Summit. It's October 9 and 10, Wednesday and Thursday. So it's going to be mostly a Middle Eastern style conference, a lot of the top investors in the Middle Eastern communities, Miami. And we want to have basically a goals, embodied a goals today. That's not security yet. It's you there to grants actually curated a Google spreadsheet to get the goals, your
physics, like, do the mind-machine interface type of situation with demo as well, kind of like real-time board type stuff, so cool stuff. It's actually beyond GPT, so it's the thing that they emphasize. They want to see what's coming on hand, like drones, robotics, like a lot of automation that goes on LLMs. LLMs are cool as well, but they want to see what else is out there. So it's a good opportunity. So Tom Milborn is going to do the pitch night and teach you how to create a pitch deck for AI investors, and we'll have some basic pitches as well. Quick pitches. So it's basically community curated from the local point of view and from the international point of view, people applying from around the world to business. So definitely talking to somebody individually, like beyond just crowdsource and AI. And so regular video, like I do on the video developer that's in South Florida, we did we used GPT to train software and go farms type thing. So I want to show that. So there are cool things you're doing, like the software internals and stuff. This app for AI too, and see what you can build. So you got a month, so and just talk to Grant to actually put you on this. Amazing. Every week, this is what we do. We bring together the land population so that we can create amazing things together. We learn every single week, so we can say we put together conferences, summits, workshops, etc. And we also make incredible inventions. We have the greatest machine learning engineers, LLM engineers, and great enthusiasts, business professionals that are using AI in their lives. And that's what we strive to do. So I want to give a round of applause to everybody here. You want to say something as well? AI Salon, we're doing something very soon as well. We're doing a lot of collaborations and also official elections.
Yes, our next AI Salon is going to be September 17th on a Tuesday, exceptionally, Monday. But what I wanted to say is that I met someone here that is organizing the next hackathon at the end of the month. Chris, where are you? He's on now. Okay, does anyone have the information on the next hackathon? Do you have it now? Yeah, the FIU. Can you maybe share it with maybe there are people interested?
Yeah, so there's a registration process, so if you're interested, you should go to the Shellhacks website and just you have to submit your resume, and you gotta have it be approved.
Yeah, the registration was due yesterday, but they have extended it for 2 weeks.
Until Sunday, I heard.
No, it's until 15th of September, so you have 2 weeks to register.
What's the website address?
Yeah, someone told me, the organizer, that it was going to be until Sunday, this Sunday, I don't know why, but he told me at the beginning of the talk.
It's Tuesday right now, it was due Sunday, but now it's extended for 2 weeks more. On shellhacks.net, you can register.
Shellhacks.net.
Shellhacks.net.
Amazing.
Thank you.
And our international business developer, she's amazing, incredible person, really is helping make GPTuesdays go to the next level. So thank you.
I just want to say Grant has all my contact information. I'm helping to organize my own constantly, so the date's not set yet. And I'm also having a lot of collaborations with Wolfson in India, and my current affiliate coming here to the US. We're having a lot of fun for education, and she is coming to Miami. So just keep it up with that, and we'll try that.
Thank you, everyone, and that's exactly what this is all about. Spreading education and really emerging technologies into Miami so we can be one of the leaders, if not the leader, in the United States. Maybe you want to help Larissa.
Well, just
Our really great help as well, every week, helping every single week, it's giving us so much.
Always helping. Any pictures or you guys
have gotten email yet, sure, but everybody just wanted to update you guys.
Thank you so much for our ambassador of GPTuesdays is always doing amazing, always helping out. So I really want to say thank you. I really, really do. So yeah, please, anyone, if you enjoyed the show today, enjoyed the education, we're always learning more from this, so please give us a tag at GPTuesdays, LinkedIn, Twitter, Instagram, you name it, YouTube, right? We have a live stream there. We always want to watch that. And yeah, our Discord or whatever. So again, thank you all so much. I think, last thing, maybe not last thing. Oh yes, let's get a picture because this is, an AI center, right? Let's get that after this. And beyond that, one last thing is we are partnering with the Gen AI Collective. On September 24th, we are doing a joint collaboration. They are now from Silicon Valley. And so, yeah, so we are excited for this joint venture. We'll be doing a research roundtable together, and it'll be very, very exciting.
Is there a QR code for that?
And we need more QR codes. We need more names. I don't know if we can make it.
He's talking about the
For the 24th, the QR code for that. I'm not sure if we can create that.
You need as many links.
Yes. We need more. I'm SWARMS, yes, as we all know, can create tens of thousands of agents and run this quickly and without any problem. So thank you all again so much. Let's just have some great conversations, and I look forward to seeing you next time.